big bummer because they were super convenient. And we really used a lot of them. So what do we do instead? So the most common suggestion is that we add in another wave of data. When you have, now this is like, I know that this, of all my suggestions, this is the largest of my suggestions for improving studies. But 3 waves of data means that you go from not being able to make any conclusion to being able to make conclusions. Because once you have this extra wave of data, you can distinguish between those stable traits and the cross-lagged paths. They're really necessary. And so instead of estimating this model, you actually estimate something called a random intercept cross-lag panel model, which has this terrible acronym. So this is, I hate saying this whole thing out because it's tons of words. So just to be clear, nobody else does this, except I've only heard one other person do it, who I'm copying. But they suggest we should pronounce the acronym Rickleton, which I think is great. But I want to also be clear that this is not widespread, so use at your own risk, okay? But we have the Rickleton. See, this just rolls off the tongue. So the random intercept cross-lag panel model looks more like this. You have a stable variance for scarcity up here that is used to predict the observed data at the 3 time points. You have the stable variance for prejudice, or stable trait for prejudice, down here doing the same thing. And then we have this big loopy arrow is representing the covariance between the traits. So this just said, this will tell us if people who have experienced more scarcity, they tend to also be the people who express more prejudice. So we get no causality out of that. That is just a correlation. But it's a fancy correlation because it has these trait parts to it. Our cross-lag paths, these can get that causality. There needs to be a few assumptions made, but it's not too bad. And what these indicate is that for this path here, it's when a person has a higher scarcity than they normally would at time 2, do they have a higher prejudice than they normally would at time 3? That's what that's looking at. And the reason there's this phrase than they normally would is because this here is kind of taking out the mean level differences between people. So when you're estimating these stable traits, this is the kind of the random intercept part of the model. It's taking out those individual differences across scarcity or across prejudice. So the advantages here is that we get estimates of the things we care about, which is nice. A disadvantage, well, yeah, I have another advantage, sorry. There's fewer spurious results. The simulations on this, unfortunately nobody who ran simulations made a nice figure for it, so I don't have a figure on here. But the simulations suggest that if there's almost any amount of stable variance, so there's any amount of trait-like component to this stuff, then the cross-lag panel models fail. And they'll tell you that there is a cross-lag effect when there is not one. And so then we'll be writing papers and building theories on effects that may not exist, which is not ideal. The limitations here is that you still require additional assumptions to make causal conclusions. This paper by Roar and Mariana do a nice job outlining what those are. The other limitation that I realized I forgot to put on the slide is that sometimes they're just harder to get the models to work right when you're doing the analyses. Part of this happens when things are super, super stable, which is not, depending on your topic, may or may not happen very often. And so there's a little bit more like modeling complexity that can go on, but not always. It's also important to note that this is not, model's not necessarily the right choice for every circumstance. I think sometimes, at least for like how I was trained, it was like, oh, you want to look at something longitudinally, cross-lag panel model, this is what you should do. Now I learned that the cross-lag panel model is not a good idea, so then I'm like, oh, the random intercept intercept cross-site panel model. That's the one that I should do. But there's actually a bunch of other alternative models that have different assumptions and might be better for different situations. And I would just encourage you to look at those before you design your studies, run your analyses. This paper by Rich Lucas, who's one of my colleagues at Michigan State, outlines some of those pretty clearly, I think. So this, I find the cross-line panel model stuff when I first read about it, and then I read about how it has a lot of spurious results. I find really concerning. It's really it's honestly kind of frustrating because it would be really nice if it worked. And so, unfortunately, to solve it, we have to add another wave of data. And for any of you who have conducted longitudinal studies, you know that this is hard. You have to, get people to come back and fill out your survey. If you're paying participants, you have to pay them again. And so you have to worry about attrition rates and all of these things. I understand that this is complicated and it can be more expensive. On the other hand, it's useful to think about what the trade-off is here. The trade-off is 3 waves of data instead of a 2-wave study that can't do what you want it to do. And so, if the 2-wave of data study doesn't work, and we're not getting good estimates from that study, or estimates that are unambiguous, that's a real problem. We really want to avoid that. And so, it's actually, I think, at the point with these cross-like panel models, unfortunately, that if you want to do a cross-like panel model study, you should skip 2 waves and go to 3. So don't plan a 2-wave study, do a 3-wave study. On the flip side, if you're like, I can't do 3 waves, which I'm super sympathetic to because it's a pain. If you can't do 3 waves, then if you have to kind of adjust your goals. But I would actually just put double the money into wave 1 and do a bigger wave 1. It's cross-sectional. You don't get causality out of it. That's a downside. But I think or I run 2 one-wave studies or something. I think that's useful. The 2-wave designs, you can do some things with them that can be useful potentially. So you can do stuff like, you can look at how stable stuff is over time. Depending on your project, that's a useful piece of information to have. If you are doing like a 2-wave design where something important happens in between, you can sometimes, or as like a natural experiment, that can be useful. But that's, depends a lot on what your design and your study is. So this is, I know, my most annoying piece of advice because I'm like, go collect more data and use a more complicated model. But on the reviewing and editing side, the 2-wave models, I think, have not entirely, but are close to not getting through peer review anymore. And so I really think, like, if you want to do a longitudinal study, this is at the point where there are almost